Pascal's triangle, that really cool triangle we looked at. We filled in some missing terms and we talked about different patterns. So now we're to the point where we're going to see another sort of interesting part of Pascal's triangle. Okay. The one weird thing about Pascal's triangle is when you're labeling rows, we actually count the top row as row 0. Okay, and then the second row is row 1, so on and so on. So Pascal's triangle can be written as combinations. If you want to check any of these with your calculators, you could type them into your calculator as we type them in, or as we write them down. But in row 0, 1, is a combination of 0 items chosen 0 at a time. And we kind of talked about that when we did 0 factorial, like why is 0 factorial equal to 1? That sort of goes against what we think. But it was like, if you have 0 items, how many ways could you arrange those items? 1 way. You don't arrange 0 items. Okay, so it's weird because you want to say 0, but the answer is 1. Okay, so that's true for combination. If you have 0 items, how many ways can you pick 0 of them? 1 way. You don't pick anything. Because not picking something is a way to do something. Okay, the second row, which is really row 1, is a combination of 1 item chosen 0 at a time, and a combination of 1 item chosen 1 at a time. Think about that. If you have 1 item to choose from, how many ways can you pick 0 of them? 1. You don't pick it. If you have 1 item, how many ways can you pick 1? 1 way, you pick it, right? It's like pretty basic. Okay, row 2. Row 2 is a combination of 2 choose 0. If you have 2 items, how many ways can you pick 0? 1, you don't pick them. That's this number over here. If you have 2 items, how many ways can you pick 1 of them? 2 ways. I pick item A, or I could pick item B. That matches this number. If I have 2 items, how many ways can I pick 2 of them? 1. I pick both. The only way to pick both of 2 items is to pick them. I'm going to do one or the other. I've got to do both. Okay. So as we go down, here's our row 0, row 1, row 2. You could imagine what row 3 is, right? Combination 3 choose 0, combination 3 choose 1, combination 3 choose 2, combination 3 choose 3. Are you on to my pattern here? And again, if you don't believe me, type these into your calculator. But if you stop and you think about them, it makes sense. Like, if I have 3 items, item A, B, and C, how many ways can I pick 1 item? 3. I pick A, or B, or C. Okay. So these things should make some sense if you stop and you think about them. But what I want to do here is kind of like just alert you to there's a connection. When we did this back with polynomials, when we first introduced Pascal's triangle and we tried to expand binomials, we would have 3 parts. And the first part was the coefficient from Pascal's triangle. Well, you had to know the rows of Pascal's triangle. The binomial expansion theorem replaces this like pick the correct row of Pascal's triangle and lets you just do a combination in place. So now we're going to write down the binomial expansion theorem. I want to make sure I write it down like your textbook, so give me a second. I'm going to look it up. I want to use the same letters. See, I did A plus B to the N. Yeah. Okay, so if we're expanding for any positive integer n, that means we're raising it to the first, the second, the third, the fourth, the fifth. We already did this back with polynomials. Then this is going to be how we can expand it without having to say find the row of the Pascal's triangle. So on that picture, to get that first one, the first coefficient was always a 1, it's always the total number choose how much? 0. So it's going to start with the total choose, which is your exponent, n choose 0. That's going to get us our coefficient from Pascal's triangle. And then we have to multiply it by the first term raised to the highest exponent, which will be n, and the second term raised to the smallest exponent, which will be 0. And then we're going to do a plus. And now to get the next number that comes from Pascal's triangle, that's on the second value, right? The second coefficient. Well, these are all your total choose 1s. So we're going to do n choose 1. We have to decrease our exponent by 1 on the first term, increase our exponent by 1 on the second term. Okay. Now, I could get myself into infinitely many terms here. So what mathematicians do is they just say plus dot dot dot, and I'm going to pick that back up over here because eventually it has to end, right? Because I'm raising it to the nth power. There's only a limited number depending on what my n is. Okay, so I'm going to go back up to my Pascal's triangle. The last one is always your total choose that number, right? Like 2 choose 2, 3 choose 3, 4 choose 4. Well, our number that we have is n. So we're going to be ending with a combination of n choose n, which is always 1, right? Like the last number in every row of Pascal's triangle. Your first term will be to its lowest exponent, which is 0. And your second term will be to the highest exponent now, which is n. Now, in terms of using binomial expansion, I'll say this. I know how to start. I know that I start with n choose 0. My first term has to have the highest exponent. My second term has to have the lowest exponent. Notice the number that you're choosing and your exponent on the b is always the same. And then if I need to expand the full binomial, I can just follow my old patterns that we talked about back with polynomials. I'm going to go up by 1 here. My exponent is going to decrease, and this exponent is going to increase. So let's do the example so we can see this with actual numbers. We're going to expand 2x minus y to the 4th. Okay, now, some of you may find this helpful. Some of you may not need to do this, but I will do this in this example just in case you feel like this is something that's helpful for you. What is A? The first term is 2x. What is B? Negative y. And what is n? 4. Okay. So if I want to expand this binomial, I know n is going to be the number that I'm choosing all my combinations from. So it's going to be a combination of 4 choose something. And I always start with 4 choose 0, the lowest number. So we're going to do a combination 4 choose 0 times 2x to the highest exponent 4 times negative y to the lowest exponent 0. And remember what we said, the number that you pick and this second exponent should match. And I want to add to that a combination of 4 choose 1. I'm going to do 2x. This exponent is going to decrease, and this one is going to increase. And again, the number that I choose and my second exponent still match, right? plus a combination of 4 choose 2, 2x squared, negative y squared. And I just keep going until I get to that last n choose n, right? So I still have to do, I'm going to give myself a little bit of space to write some of those. 4 choose 3, this is going to be 2x to the first and negative y cubed. And this is going to be 4 choose 4, this is going to be 2x to the 0 and negative y to the fourth. Are we okay with where my numbers and terms came from? Are there any questions or clarifications you'd like to make right now? This binomial expansion theorem you're going to see again in Algebra 3 or Pre-Calculus, but it is super helpful because it doesn't just rely on like, oh, the numbers in Pascal's triangle. I don't have to know or write down Pascal's triangle. I can generate the coefficients through the combination. Okay, so we already know what a combination of 4 choose 0 is, right? 1. Be real careful with 2x to the fourth. What do you have to remember to do? Distribute to the 2 and to the x. So this is 16x to the fourth. And then anything raised to the 0 is 1. So 1 times 16x to the fourth times 1 is 16x to the fourth. I'm going to write that up a little lower so I have room to put the other one. Okay, there's my first term. Okay, now I'm going to do my second term. This is a plus. A combination of 4 choose 1. You could type it in, but a combination of anything choose 1 is that thing. So this one's going to be 4. Got to distribute. That's going to be times 8x cubed. And then what's negative y to the first? Negative y. Now, this happened to a lot of people in polynomials. They wrote like minus y. That's not minus y. That's times a negative. So when I take a positive times a negative, it's going to be a negative. 4 times 8 is 32. X cubed times y looks like that. Notice my minus should not be in front of the y or it will look like subtraction, not multiplication. Those things are getting multiplied. Now, a combination of 4 choose 2, I might use my calculator. Can anybody do that for us? Combination of 4 choose 2, or you recall from Pascal's triangle? Number is? Not 4. 6. Times, this is going to be 4x squared. What happens to negative y squared? Y? Negative y times negative y. Y squared.
So why is it a 1, 4, and 6?
Those are combinations. Do it in your calculator. I'm doing combination 4 choose 0, combination 4 choose 1, combination 4 choose 2. Those are their numbers. That's now positive 24 x squared y squared. Okay, moving right along. What about a combination of 4 choose 3? 4. If you know Pascal's triangle, I'm not going to be able to tell if you typed that into your calculator or you got it from Pascal's triangle. Either one is fine with me. In my later examples, it might be useful to know the combination. This is going to be plus 4 times 2x. What happens to negative y negative y cubed? It's negative. So this is times another negative, and now it's y cubed. Okay. Please do not write this as 2x minus y cubed. It's not subtraction. It's multiplication. A positive times a negative is a negative. So it's just going to have a negative coefficient like this 32. Okay. That would be negative 8xy cubed. Okay. And the last one, this one you should probably be able to figure out. Combination of 4 choose 4 is 1. There's one way to pick everything. Pick everything. Anything raised to the 0 is 1. So 2x to the 0, both of them, 1. And negative y to the 4th? Y to the 4th. So then we just have plus y to the 4th. Well, we just expanded the binomial. Now, remember if you're like A and B are different signs, one is positive and one is negative, then when you look down at your final answer, you should have alternating signs. Like it should go positive, negative, positive, negative, positive, negative. If A were negative and B were positive, then it would switch. It would go negative, positive, negative, positive. Okay, but you should notice that pattern, and that's a nice way to tell if you've made a small sign error, right? You have a question?
In the fourth one, shouldn't it be 8x?
Oh, yeah, I did live off my x. Thank you, Luke. Should be 8x cubed, 8xy cubed. I'm sorry, if you're copying from the board, make sure that you fix that out. Plus. Any other questions you want to ask about? Okay, so we did this in first semester. This is our second go round. Think about it as an opportunity to get better at something that we've already done. Things should be easier the second time around. So if you felt really like you never got that in chapter 4, you can get it now, and you're going to see it again next year. Now, I got 2 other examples that are not quite so much work, but they do require some thought. Okay. Oops. I thought I had other examples. Maybe I moved my hands. There they are, behind my homework. Okay, we want to find a coefficient for x to the 5th in the expansion of x minus 4 to the 7th. Now, do I want to expand the whole thing? No, I'm lazy, right? That seems like just to get the coefficient of x to the 5th, I don't want to know all the terms that precede x to the 5th. So what I think about is in my binomial expansion theorem, there's 3 parts, right? There's a combination. There's my first term raised to something. And there's my second term raised to something. So I have a combination. I have x raised to an exponent, and I have my second term, which in this case is negative 4 raised to an exponent, right? There's like 3 parts to every term. For my combination, what's the total that I'm going to be choosing from?
7.
7, because that's the power, right? So n is equal to 7. Okay, this is probably the trickiest part of the whole thing. What are you choosing?
No.
You would start at 0, right? And then it would be x to the 7. And then if you chose 1, it would be x to the 6. So if you did choose 2, you're at x to the 5th. Okay. So it's just like, think about it. So we're going to do combination of 7, choose 2. And then this is how I do it. This 2 matches which exponent? The one at the end. So this is negative 4 squared. And then that means that this one must be x to the 5th, which I guess we could have also filled in that one, knowing that had to be x to the 5th, and then done 2 and match the 2 here. And then just figure that out in your calculator. Can someone do combination 7, choose 2? I don't know that one. 21. 21 times x to the 5th times 16. Give us a number there. 336. X to the 5th is the term, so the coefficient is 336. You want to work the third example with your pod members and we'll talk about it? even know anyway. But it could be very large when you think about it. Every term is made up of 3 parts. Okay, total that I'm choosing from? 10. Number that I'm choosing?
4.
4. Matches the one on the outside. And this one must be 6 to get x to 6. Now, one thing you could do, since this is just asking about the coefficient, is in your calculator, do a combination of 10 choose 4 times 2 to the 6 times 3 to the 4th, right? You know x to 6 is going to give you x to 6. So I got 1,088,640. You know, I usually don't ask you to expand things to powers of 10, right? So when you think like maybe our numbers got big, the coefficients can be very large if you have larger powers.
So, like, how did you get the 4?
Well, so if you want to get x to the 6th, this has to be raised to the 6th, and then they have to add to make 10. Or you can think about it like, if you're doing the combination or you're doing the binomial expansion, you start by choosing 0, but then this will be raised to the 10th, raised to the 9th, raised to the 8th, raised to the 7th. Oh, because I'm counting the terms, not the exponent. But yeah, so then I'm going out 4, and that's the number or I'm going out 6. Okay? Okay, your homework assignment is at the bottom of the page. We've got a nice chunk of time. Everybody should be working. You've got over 15 minutes remaining.